All right, everybody. Hope everyone's doing well. Welcome back. We're going to start up with a new lesson. For those of you who are following along or want to follow along with the textbook, we are on Chapter 10, Section 1, and this chapter is all about circles. Now, I know you can pick out a circle, probably draw a circle. It might not be perfectly straight, but you know, everybody has an idea of what a circle is. We're going to learn what a circle is as far as geometry is concerned. So, a circle is defined as the set of all points in a plane that are equidistant from a given point. Okay, so do you remember what that word equidistant means? Equi, like equal, distant, distance. So equal distance from a given point. So let's say, for example, we have a point. Let's call this point A. And let's say that we draw all the points that are the same distance from this point A. So let's go with the distance about, I don't know, that long. So let's start drawing all the points that are about that same distance. And what happens is if we keep on drawing all the points that are that same distance from point A, eventually we'll fill in this so much so that we have a circle. And that's the geometric definition of a circle. It's all the points that are equidistant from this point right here, which would be the center. Remember that lines and segments, they're just a collection of points. They're infinite points. So a circle, no different. Infinite points that are just drawn equidistant from that center. Now the way we write this, we have a special symbol, just like we have a symbol for parallelograms and a symbol for triangle. We draw a little triangle. For a circle, we draw a little geometric circle. There's the center and there's everything equidistant. So this right here, we would write as circle C. If we had another circle here, and let's draw a center here and say this is circle F, the way I write it in a proof or something would just be like that. All right? Now, there's 3 segments in a circle that are special that we're going to talk about. So the first one we're going to talk about, which you probably remember, is a radius. If you have more than one radius, we call them a radii. So 1 radius, 2 radii, 3 radii, and so forth. So the definition of a radius is a segment with the endpoints that are the center of the circle and on the circle itself. So the endpoints are the center and on the circle. So let me show you what I mean. If I have a circle right here, let's call this circle K. See what I did there? Circle K. Anyway, if I have a circle right here, this is the center, and this right here, the circle itself, that's the circle. So we would say a segment that goes from here right to that outer edge, to the circle itself. Let's call this A, point A. This is a radius. So this would be radius KA. If we drew another one, we also have radius KB, and so forth. So a radius is just a segment from the center to the circle. The next one, a chord. So a chord is also a segment, but both endpoints are on the circle itself. So let's get our definition. So let's say that we have circle E. A chord is just going to be a segment with both endpoints on the circle. So let's say from here to here. Let's call this A, B. So that's chord AB. Notice that we have endpoint here on the circle, endpoint here on the circle. Now, the last one is called a diameter. And chances are in algebra in your classes before, you heard about radius and diameter and not about chord. The reason why I taught chord second is because a diameter is a chord, but it's a special chord. It's a chord, meaning, remember, chord has both endpoints on the circle itself, but it's a chord that passes through the center of the circle. All right. Oh, and I'm off my video. There we go, that's better. Now you can see that. So, circle A, and a chord, it's gonna have endpoints on the circle, but it's gotta pass through the center. So what I'm gonna do is I'm gonna draw a radius in this direction and a radius in this direction. Now notice these two radii, they're collinear. They make a straight line. They're not like on an angle like that. They form a straight line, collinear, that's 180 degrees. So let's call this point B and this point C. So we would say that this is diameter BC. So notice that I said that these are radii from the center to the circle, center to the circle. So we're going to use that for the relationships that we have between radius and diameter. And let's go into those relationships right now. All right, relationships. Oh. Now, we in particular are going to talk about the relationships between radius and diameter. So again, remember we were talking up here about diameters, and I told you that the diameter is made up of two radii, and those two radii are collinear. So because a diameter is made up of two radii, what we can say is if you have a diameter and you divide it by 2, you're going to end up with a radius. Likewise, the opposite's true. If I multiply by 2 on both sides, what I would find out is that 2 times the radius would equal the diameter. So let's see how that works with some numbers. If I've got a circle right here, and let's say I have a diameter, and let's say this diameter, the whole entire thing, is equal to 10 feet, inches, whatever, it doesn't matter. Well, here's the thing. If this whole entire thing equals 10, and I know, and I don't know if you hear that, my son says hello. So if the whole entire thing has a length of 10, then that means that both of these, if they're both radius, they're both the same distance. So that means that this has to have a length of 5, and so does this. And let's put this into the formula so you can see where these numbers came from now that you understand the explanation. Take the diameter, which we said was 10, divide it by 2 to get the radius. See how that works? Now the opposite's true as well. Let's say we have a circle here, and let's say this is a radius of 3. Well, if that's a radius of 3, what's the diameter equal? Well, 2 times the radius equals the diameter. So 2 times 3 would equal 6, and that's the diameter. All right, I hope you feel like you have a good understanding of the basics of circles. We will do some problems and practice on it.